12, Lab 1, Charge Tape by Llano-Cruz. So the introduction, the purpose. In this experiment, we investigated how ordinary objects become electrically charged through contact and separation, depending on the materials involved. Rubbing, pulling apart, or even touching can transfer electrons or ions from one object to another, leaving one object with an excess of negative charge and the other with a net positive charge. Although we know charge is quantized and therefore it cannot be smaller than the charge of a single electron, estimating the total excess charge on a common object, such as a piece of clear tape, is not straightforward. In principle, the charge could range from extremely small values up to unrealistic large amounts. So we need an experimental method to narrow it down. The purpose of this lab is to determine within order of magnitude the excess charge on a piece of charged clear tape and to develop an intuitive sense of how much charge everyday materials can carry. First, we will prepare and charge pieces of clear tape and qualitatively observe their electric interactions. Then we will connect these observations with quantitative estimates by building a computational model. Each tape will be approximated as a single point charge located at its center, and the model will include both the electrical force between the tapes and the gravitational force on the suspended tape. Some key physics principles are Coulomb's law, the electrical force between two charged objects, which is Fe equals K over Q1, Q2 over R squared. So both of the charges multiplied by K constant over the distance squared, or the separation between them. Superposition and position charge approximation. When modeling the system of each piece of tape is approximated as a point charge located at its center, this implication allows the electrical interaction to be calculated using Coulomb's law while still capturing the essential behavior of the system. And the gravitational force equals mass times gravity, moving most times in the negative direction because obviously gravity pulls us down to Earth, but depends on the situation. As a result, the two pieces of clear tape that were approximately 8 inches long with a mass of 7.8 e to the negative 8 kilograms were electrically charged to one another. Because they were electrically charged, when they're brought together, they would float about a distance of 1 centimeter. This force was calculated to be 7.6 e to the negative 7 newtons. Using a computational model that included Coulomb's law and gravity, the magnitude of the charge on the tape is approximately 9.2 e to the negative 10 coulombs. So here's my coding. I had the initial conditions and then the loop for the calculations. I used Coulomb's law, the gravitational force, and Newton's second law to do the calculations, and the initial conditions were based on the measurements that we took in lab. Some errors could have been handling the tape, the oils in the finger, and our positively charged cells affecting the charge of the tape itself. Tape mass estimation, because we were given parameters for which to estimate the mass of the tape and however inches it was, there could be an error in that. And then the distance measurement, because we were only given an arbitrary ruler to measure the distance might not be accurate as it was fluctuating between a positive and negative y direction. Application and results. So what if electrons carried positive charge and protons carried negative charge, the labels we used for charge could reverse. Objects would still become charged through contact and separation, but the charge states would still retract and repel in the same way. The only difference for which type of change we call positive and negative doesn't really matter, since the physics depends on a relative charge and the force direction, not on the sign of convention. The behavior of the tapes would look the same. It is important. So why? It is important to handle the charges of the tape as little as possible because touching the tape allows charge to flow from the tape. So again, as one of the errors, are positively charged cells affecting the charge of the tape itself. And that is the experiment. Thank you for listening.